Factorial experiment example. An experiment was conducted on 3 decks, to compare the loss of material, in pounds, in 3 types of cuts, C = Sierra, P = polishing, A = acetylene, to compare which of the 3 cuts produces more loss, and were obtained individual weight data of each slice as shown in the following table, in which we use the digital scale. Note: we will use C as representing sawing. Well, these are the collected data of the experiment. This indicates sawing. This indicates the cutting polishing. And, cut with acetylene. Well, with this information we pass to the realization of the first test, F max. Started. Step 1. The null hypothesis will do the same to loss of materials saw the square, equal to the loss in polishing the square, and equal to the loss acetylene squared. Step 2. Alternative hypothesis, will do the same material loss saw squared, but not equal to that of the lost material squared, but not equal to the squared acetylene. Step 3. In this way we have a 95% confidence, and an alpha of 5%. Step 4. N sub 1 represents the number of column data, and total number N sub 2 data. Step 5. Formula, F max. We seek this information in table F max. All in, step 6. We develop the formula. Finding the value of the average of the mountain, the polisher, and that of acetylene. This table shows the values as shown operated. These are the data, obtained from each cut into deck. This is the operation data plate, minus the mean squared. This is the result obtained. The result is divided between the N sub 1. Step 7. Well, in cutting polishing and cutting acetylene, we do the same as in sawing. Well, then move to what is the development of the following formulas. Step 8. This is the normal curve in which we place the value found in table F max conducted in step 6, and the value found in the previous step. Step 9. Therefore, we can say, we accept the null hypothesis. Step 10. Conclusions. In the 3 types of court no difference showed loss of material, since only the cuts were performed and not performed treatment for the purpose of the part. Test, F ANOA. We use the same starting table. Scatter diagram. In this diagram we can realize that the biggest losses are produced by the cutting polishing, followed by the sawing, and cutting with acetylene less material is lost. Step 1. We had the development of formulas. Obtaining the result of the mountain polisher, acetylene. Continue taking the middle, and then stockings, tights. Step 2. The null hypothesis will do the same to loss of materials saw the square, equal to the loss in polishing the square, and equal to the loss acetylene squared. Alternative hypothesis, will do the same material loss saw squared, but not equal to that of the lost material squared, but not equal to the squared acetylene. Step 3. N sub 1 operator to the amount of data in the column and the total number N sub 2 facts. Step 4. In this way we have a 95% confidence, and an alpha of 5%. Step 5. Development of the following formulas. Step 6. Step 7. Table of degrees of freedom and sums of squares. Good friends, follow the order of operations as indicated by red boxes. Development of formulas. Multiple comparisons, Tukey-Kramer. Where C means number of columns. We continue with the development of reach critical. Replacing data with the formula. We get the absolute values if an answer given negative sign is omitted. Comparison. We realize that the second data is further from the reach critical. Conclusion. We realize that although all are below the critical range P, polishing becomes more material loss. Conclusion. In the three types of cutting showed no loss of material difference. Remember. The only limits that exist are the ones that you put yourself.